Hi guys, in today's video we're going to be learning how to calculate the gradient of a straight line. Now, before you get started with this, it's really important that you have a bit of prior background knowledge first. So the most important skill is that you can label points on a graph and you know what these labels are referring to. So for instance, you should know that we go along the corridor and up the stairs. So we label the x-axis followed by the y-axis. So each of these points here, we would have 4, 1. This one would be 7, 4. Up here we would have 3 on the x-axis and 9 on the y-axis. And all the way over here we would have 10 on the x-axis and 8 on the y-axis. It's really important that you know the difference between the x and y-axes, and that you know that the x-axis is always written first and the y-axis is always written second. However, if you're comfortable with that, then we should be able to progress with working out the gradient of a straight line. So we have a simple graph here, and it is just a straight line, and we've got 2 points labelled on it. We've got 2, 4 and 7, 9. Now our job is to work out the gradient of this line. Now the gradient is basically just a fancy word for the steepness of the line. So it's basically telling us for every box along we go, how far up do we go? Now in this case we should be able to make a rough guess, because it seems that we're going along one and up one every time, but let's actually see if we can work this out mathematically. Now there's a formula to help with this, and what we say is that m is just the symbol that we use for the steepness of a line. The line's steepness is equal to y2 minus y1 divided by x2 minus x1. So m equals y2 minus y1 divided by x2 minus x1. Now, to work out what all these y's and x's are, it really helps to label our coordinates. So we're going to label this one here, the first coordinate we come to, as coordinate number 1. We're going to label this coordinate over here as coordinate number 2. And you should already know that in both cases, the x is always the first number and the y is always the second number. Now we should be starting to see how this comes together to work out the gradient. So let's try just sticking to this formula and see if we can work out which numbers to use in each of the cases. So let's try this here. M equals y2 minus y1 divided by x2 minus x1. Okay, well, y2, what number here do we think is y2? Well, here is coordinate number 2, right here. And what's the y value? Well, that's 9. Okay, so let's treat y2 as 9. And we need to minus y1. Well, here's coordinate number 1, and y is 4 there. Okay, so y2 minus y1 seems to be 9 minus 4. And we're going to divide that by x2. Well, here's coordinate 2, and here's x. So 7 minus x1. Well, here's coordinate 1, here's x. So it's going to be 7 minus 2. Resolving that then, what we have is 9 minus 4 is 5. We're dividing that by 7 minus 2, which is also 5. Oh, that's curious. 5 divided by 5. Well, that's actually quite easy, isn't it? In this case, m equals 1. And that makes sense based on what we said earlier. We noticed that for every box along on the x-axis, we appear to be going up one box on the y-axis. So it's along one, up one, along one, up one, along one, up one. So that is why we have a gradient or steepness of 1. Okay, well let's try this on a different graph. You can see here that this graph is a little bit steeper this time. And it appears to be going up at a much sharper gradient. Let's label our points again so we know that this is going to be coordinate number 1. It's the one that comes earliest on the line. And this is coordinate number 2. And once again, let's just stick to the formula. M equals y2 minus y1 divided by x2 minus x1. So y2 then. Well, here's our y, here's our x. Here's our x, here's our y. Right. So y2, we have 9 again, and y1, we have 3 this time. So, the top part of this is 9 minus 3, and we're going to divide that by x2, which is 4 this time, and x1, which is 2. So this time, m equals 9 minus 3 is 6, 4 minus 2 is 2, so m equals 6 divided by 2. What's the answer to that? Well, it's 3. So the gradient in this case seems to be 3. And just looking at it, again, that seems to make sense. We go along 1 and up 1, 2, 3. There. Along 1 and up 1, 2, 3. So in this case, we have a much higher gradient, a gradient of 3, and so we have a steeper line. So for every 1 along on the x-axis, we go up 3 on the y-axis. Now lastly, here's one final line, and this one's a little bit trickier again, because this time it's not a steeper gradient, but it's a more shallow gradient. It's going up more gradually. So before they were going up much more steeply, this one is a much more gradual rise. So, same process. M equals y2. Well, let's label our coordinates here. 2 and 1. And we've got y2, which is 8, minus y1, which is 5. x2, which is 10, minus x1, which is 4. So m equals 8 minus 5 is 3. 10 minus 4 is 6. So we have 3 divided by 6. Okay. Well, actually, treating that as a fraction, we can simplify it. Hopefully we're seeing that this is just a fraction, and we can simplify it. So, m equals 3 divided by 6, or 3/6. Well, they're both in the 3 times table. Actually just a half. So the gradient in this case is a half. So for every 1 box along, we're going up half a box up. And so over 2 boxes along, we are going up 1 box on the y-axis. Okay, so this is a gradient of a half here. Gradient is just steepness, and as long as you stick to this formula, you'll always get the right answer. Cheers, guys!